So, good morning to all. This is Dr. Nagaraju, Assistant Professor, Department of Mechanical Engineering, JNTUACEA College of Engineering, Anantapur. Today, we will discuss about boiling and condensation. So, the boilers and condensers are the heat transfer equipments. In these equipments, the phase change equipments. So, these boilers and condensers are two important heat transfer equipments used in power plants, refrigerators, and air conditionings. Chemical processing industries also is used in boilers and condensers. You know boilers, you know condensers. So boilers is nothing but the water gets converted into vapor, and condensers is used to vapor gets converted into liquid. So in this scenario, when a liquid is in contact with a solid surface which is maintained at a temperature higher than the saturation temperature of the liquid, boiling occur, the liquid is converted into vapor. During the boiling process, the pressure and temperature remains constant and the latent heat is added to the liquid. In this become a vapor. In condensation process, the vapor gets converted into liquid. In this process, the vapor strikes on the surface which is maintained at a temperature lower than the saturation temperature. The vapor condenses on the surface and converted into liquid. During the condensation process also, pressure and temperature remains constant and the latent heat is released by the vapor, isn't it? So this is the overview of the boiling and condensation. So in this boiling and condensation process, so the types of boilings and also boiling curve, heat transfer correlations and condensation, the types of condensation, the rate of heat transfer. In this condensation process, film-wise condensation on a horizontal tube. So here, coming to boiling process, boiling begins when the liquid is heated to the point at which the pressure of the saturated vapor above its surface becomes equal to the external pressure. So here, in this boiling process, the liquid boiling process, the heat is expanded in the formation of bubbles must be supplied. Thus, the boiling is inseparably associated with heat transfer, which results in the transmission of heat from the heating surface to the liquid. The heat exchange during the boiling is one of the forms of convective heat transfer. So, in a boiling heat transfer process, the boiling regions in pool boiling process. The four boiling regions in pool boiling process. One is the natural convection boiling process and nucleate boiling process, transmission boiling process, and film boiling process. So here in these types of boiling processes are one is pool boiling and second one is flow boiling. Here you look at this one in a pool boiling process. The fluid is not forced to flow by a mover like a pump. Any motion of the fluid is due to natural convection. The surface temperature greater than the saturation temperature, so the boiling will occur. Look at this here, here's the flow boiling. In this slow boiling process, liquid is forced to move by an external source like a pump. Liquid is forced through the tube with temperature Ts. Heat is added through the wall of the tube. So coming to boiling curve. So here in this boiling curve, the the excess temperature is taken on x-axis and heat flux is on y-axis in the boiling curve. So in this excess temperature, the curve plotted like this from 1 to A to B, and also B to C to D, and D to E. This is plotted a boiling curve. So from 1 to A is a natural convection boiling process, and A to B is the pool boiling process, and B to C nucleate boiling, and also C to D is the film boiling process, isn't it? So here from A to B, the bubbles collapse in the liquid formation. From B to C is the bubbles raised in a free surface saturation period. So the C is the maximum heat flux, critical heat flux in a C point maximum. So the D point is lead force point. The C1 is the lead force point. So process, in this process for a heat flowing process, in a boiling curve phenomena, in a boiling curve phenomena, one is nucleate film boiling, and also second one is the natural convection process. So in this natural convection process, in this natural convection process, a superheated liquid rising to the surface, and evaporation takes place from the free surface. In natural convection phenomena process, the fluid motion from 1 to A, the fluid motion in this mode of boiling is governed by natural convection, and the heat transfer from heated surface to the fluid also by natural convection. So in this natural convection process, the bubbles move up the free surface where they break up and release their vapor content. So nucleate boiling is the most desirable boiling regime in practice because high heat transfer rates can be achieved in this regime. So next one is the transition boiling process. In this transition boiling process, the temperature difference is increased at a point C. The heat plus then decreases. So this is because a large fraction of heat surface is covered by a vapor film, which acts as an insulation due to the low thermal conductivity. So coming to next one is the film boiling. So in this film boiling process, the regime of heat surface is completely covered by a continuous stable of vapor film. Here look at this complete stable vapor film. So the point D, where the heat flux reaches a minimum, here in this point D, the heat flux reaches a minimum, that is called the lead force point. That is called lead force point. So in this four boiling processes, uh, four boiling regimes is there. So then we all film boiling and also nucleate boiling is by using this boiling processes, we correlate heat transfer correlations. By using heat transfer correlations is calculated. So and then we discuss about condensation. In this condensation process, the vapor gets converted into liquid, This condensation process is in two types. One is film-wise condensation and another one is drop-wise condensation. In these two condensation processes, we are preferred only film-wise condensation process. Because of the film-wise condensation maintenance is very low as compared to drop-wise condensation. Most of cases, drop-wise condensation maintenance and also so many technical problems is erased in drop-wise condensation. So that's why we are preferred in film-wise condensation only. Okay. So then next class onwards, we will discuss about condensation process. Okay. Thank you. Thank you.